Hi and welcome to the fifth video on kinematics. In this video, we'll be making use of the kinematics equations. Let me write a few of them down. We have about four main kinematic equations. One is velocity is equal to v0, the initial velocity, plus acceleration times time. The second is velocity squared is equal to initial velocity squared plus 2a s. A and s is acceleration and s is displacement. The third is displacement is equal to initial velocity times t plus half acceleration times time squared. The fourth one is displacement is equal to final velocity plus initial velocity over 2 times time. Now, this one is rarely used, but we include it. So when solving such kinds of questions, we generally follow these three steps. Number one, we write down the information given. So in this case, when you read the question, information such as the initial speed, the final speed, if there's displacement, a certain amount of time, we look for all those things and write them down. After that, we choose the appropriate kinematics equation that can give the answer directly. So after you've read the question and seen what you're being asked, in this case, there's something like acceleration and time, you now have to choose the appropriate kinematic equation that can give you the answer directly. For example, if you've been given initial velocity, also you've been given acceleration and time, and you're asked to get velocity, equation 1 would be the best to do that. However, if you're not given time, perhaps say you're given displacement, you're given final velocity, you're given acceleration and displacement, and you're asked to get the initial velocity. Because this equation 2 has the final velocity, it has acceleration, it has time, you can make initial velocity the subject and get the answer directly. Now, there will be instances where we cannot get the answer directly. In that case, we have to make use of two of the equations. So for instance, you might have to make use of this equation and equation 1, perhaps to get the acceleration, then you're getting displacement. In that case, you can use two equations. With that in mind, let's get into it. First thing we have to do is write down the information. Let's call it the data. So the first piece of information, when we read this, it says you accelerate uniformly your Bugatti from 45 kilometers per hour to 75 kilometers per hour. So 45 is initial velocity, 45 kilometers per hour, and the final velocity, 75 kilometers per hour, over a displacement of s is equal to 90 meters. So this is the information we've been given. What are we asked to get? Question 1 is asking us to get the acceleration and the elapsed time. So acceleration and time. Okay, so this is the information we have. Based on this information, we are looking for acceleration. Which equation will be appropriate? Let me write down three of the main equations. V equals V naught plus AT. Second one is V squared is equal to V naught squared plus 2AS. 3S equals V naught T plus half AT squared. Based on this information, we've been given this, this, and this. Which equation will be most appropriate to get the acceleration? So, based on all this information, we've been given initial velocity, we've been given final velocity, we've been given displacement. So we can make acceleration subject and get the answer directly. Let's go ahead and do that. So we picked on the equation v squared is equal to v naught squared plus 2as. Making a the subject, we take v naught squared the other side. Then we divide both sides by 2s. On the right hand side, these two cancel. Then it becomes acceleration is equal to v squared minus v naught squared over 2s. Now, okay, we can go ahead and plug in. But before we do, we have to convert these 45 kilometers per hour and 75 kilometers per hour to meters per second. So if we convert, this gives us 12.5 meters per second and 20.8 meters per second. Now let's go ahead and find acceleration. Final velocity is 20.8 squared minus initial velocity is 12.5 squared over 2 times displacement is 90. This gives us in the numerator we have 276.4 over 180, giving us an acceleration of 1.54 meters per square second. So we found our acceleration. Let me write it on top. Acceleration is equal to 1.54 meters per square second. The next thing we're going to look for is the elapsed time. Now we have acceleration. So we're looking for time. Which equation can give us time? So we'll use v is equal to v naught plus acceleration times time. Then we make t the subject. Making t the subject, this becomes t equals v minus v naught over acceleration. Final velocity is 20.8 minus 12.5 divided by acceleration 1.54. This gives us 8.3 over 1.54, giving us a final time of, so there we have it. Our time is equal to 5.4 seconds. Question B. You then brake your Bugatti to a stop, subjecting it to uniform retardation in 10 seconds. So we've been given another piece of time, which is 10 seconds. So you're braking. In this case, let me separate these as this is now part B. In this case, so your final velocity is going to be 0 since you're braking, but your initial velocity is the final velocity of the previous part. So it's like you are accelerating. First of all, you reach 20.8 meters per second at some point, and then you're told that you start braking for about 10 seconds. So this is now at 0. So 20.8 is now your initial velocity, and the final velocity is 0. That means that initial velocity is 20.8 meters per second. Now, based on this information, which equation can give us the retardation? The retardation is also the acceleration, but since we're slowing down, it's negative acceleration. So we can use this equation: A equals v minus v initial over time taken. The velocity is 0, initial is 20.8 divided by 10 seconds. This gives us negative 20.8 divided by 10 seconds, and giving us a retardation or an acceleration of negative 2.8 meters per square second. Now, we've been taught to get retardation. If we are taught to get acceleration, our final answer would be negative 2.08 meters per square second. Now, retardation, by saying retardation, it means we're slowing down. So we can just say 2.08 meters per square second. You can say retardation is equal to this. So our final answer, 2.08 meters per square second. Finally, what distance would be covered during braking? So we're being asked for the distance that would be covered during this last 10-second period. So we can put acceleration is equal to negative 2.08 meters per square second. What distance would be covered? So which equation can we use to get the distance? We can use this equation: v squared is equal to v naught squared plus 2as. Then we make the displacement the subject. If we make the displacement the subject, it becomes v squared minus v naught squared over 2 times acceleration, because we have the final velocity, we have the initial velocity, and we have the acceleration. Final velocity is 0. Initial velocity is 20.8 squared divided by 2 times acceleration. Acceleration is negative 2.08. This gives us on top we'll have negative 432.64 divided by negative 4.16. This gives us 104 meters. And there we have it. Our final answer. Displacement in the last 10 seconds is 104 meters. And we can also use another kinematic equation to get the displacement. We can use S equals V naught T plus half AT squared. Because we have initial velocity, we have time, the 10 seconds, we have acceleration, which we found in the previous step, and we have time as well. So let's try finding the final displacement. So S equals initial velocity 20.8, time is 10 seconds plus half, our acceleration is negative 2.08, and our time is 10 squared. Let me bring this here. 20.8 times 10 is 208 plus half times 2.08 gives us negative 1.04. 10 squared becomes 100. This gives us 208 minus 1.04 times 100 is 104, giving us 208 minus 104. This is 104.